let's go through volume of a cone. So here is our cone. Let's just take a moment just to review the dimensions. So we've been given 10 centimeters. That is the slanted length along there. We know the base has a radius of 6 centimeters. Now when we look at our formula for the volume of a cone, that is third times base times perpendicular height. So we've got an extra step here because we need to find the perpendicular height. Now the way we would do that, we'd use Pythagoras. So we know this slanted face here, this length here is 10 centimeters. We know the radius is 6, so these make up two sides of a right angled triangle, because that would be the height perpendicular to the radius. Now the radius squared is 36, that slant squared is 100, and remember it's the two shorter sides squared which need to add to make the longest side squared. So in terms of steps, we would square the 10, which is 100, we'd square the 6, which is 36, take it away, and then square root. So we should have something like this. So the longest side squared was 100, so 10 squared equals 100, 6 squared equals 36. Because we're looking for a shorter side, we're going to take away, so that leaves us with 64, and then this the square root of 64, which gives us the perpendicular height. Now let's look at how this all works out in the end. So it's base times perpendicular height times a third. So we're going to do a third times pi r squared times the perpendicular height. So we're doing a third times pi times 6 squared times 8, which gives us a volume. We've got a mistake there, let's correct that now, of 302 centimeters cubed, because it's a volume. So let's just put a square around our units.